Hey guys, look what arrived just in time for the 4th of July holiday. It is potentially the fix for my HP 8662A. It is a replacement A4, A7 AGC board. Before we dig into that though, I want to review what the current situation with the device is and talk about what that board does and why I suspect it is a source of my trouble. So I've recapped the power supply. The device turns on. We just have an error code 10 right now. I can dial in any frequency. That seems to be fine. The sweep seems to work fine. Frequency modulation is also working. I was using it incorrectly. When I was enabling FM modulation, it was defaulting to an external source. When I changed it to use the internal FM modulation source, it seems to work fine. The output level, I can only adjust it coarsely. I cannot get any fine control, so it jumps kind of between 1 dB steps. And I can hear something clicking. I believe those are solenoids enabling different output attenuator resistor networks, but the fine control doesn't work. So why do I suspect this board? Well, I pulled up the schematic of it here from the service info. Let's quickly review what it does. This is the edge card connector on the board. We have several inputs here, first of which is AM. That is our AM modulation coming in, whether it's an internal or external source. We have 10 bits here that says RF level control. That goes to a digital to analog converter that controls our fine output level. And we have AGC detector 0 to 4 volts. This is a sampling of the actual output of the device. They sample the RF output. By that I mean they detect it. They run it through a semiconductor converted from RF to a DC voltage. We have trouble with all of these. Our amplitude modulation isn't working, our fine RF level control isn't working, and AGC I think is maybe pegged wide open. That's why the output waveform is clipped, because it's amplifying it too much. Okay, what do all of these go to? Well, they have a digital analog converter here. It's a curious variation of one. It's called a multiplying D to A converter. They take the amplitude modulation and goes into the voltage reference, and our RF level control goes to the digital inputs. What this does is this multiplies the digital value by the voltage reference. So say we have a digital value of 512 out of a possible 1024, that will cut this in half. Now it's a current device, that's why it says I here. These are current sources. So on the output of that, I believe this is a current to voltage converter. They combine that, this heavy dashed line here, that is the AGC. They combine these two. It's these two 1K resistors. So these get summed together. Our AGC voltage, our AM modulation, and our RF level control all come together right here. And we've got a comparator, and then on the right hand side of the board things get complicated, because the way this device works is there are separate VCOs, separate oscillators, separate circuit blocks for different frequency bands. So the doubler band, that's the really high stuff. That's like the 640 to 1.2 gigahertz. And there's the middle band, and then there's the down converter. That's the low band, I believe. So that signal all comes down to one point, our control signal, and then it gets split up and amplified and scaled and adjusted to the appropriate type of drive level for the other boards. So this is really critical to all those things that are not working properly. So let's pop in the new board and see if it does the trick. Here's the old card, and there's a digital analog converter. There's the test switch. I've gone over this board. I've checked all the tantalums for shorts or any other obvious problem. I can't find anything wrong with it. But you can only do so much when you can't actually probe it when it's powered up. Let's check out the replacement. No padding whatsoever. Just an anti-static bag thrown into a box. Here it is. Oh, it is different. This is 83. This is 85. So, honestly, I like mine better because it has a nice gold-plated ceramic chip versus just a ceramic. Strange how much can change. Almost every part is a different color. The trimmer pots, the inductors, the chips. Boy, even the pull-up resistors are different packaging. Strange. Okay, but they are both A4, A7 boards, so without further ado, let's give it a try. Carefully put mine aside. Pop this guy in. Okay, here we go. That looks like a sine wave to me. 50 megahertz. Let's do have an error status light going now. Still says error 10, but the error light is not on the board. We have something going on. I just enabled AM modulation. We have AM modulation. It's overmodulated. I do have 85% modulation on right now. Let's do more like 30. Hey. Come on, trigger on the peaks. Come on. I'm dialing a little bit lower frequency. Cut my amplitude down a little bit too. I got plus 15 dBm coming out of this thing right now. It's a little much. Oh, wait a minute, hang on. Let's see if the fine. Okay, I am decreasing the amplitude, and it is decreasing. Ha ha ha. So, what I'm doing is I'm holding down. It's light for you guys. I'm holding down this button, which makes that go down. Let's look back at the scope while I hold that button down. The waveform is slowly getting smaller and smaller and smaller, exactly like it's supposed to do. Until it should start to fade away completely. Fantastic. So we still have an error code, but there are no errors on the device, and it seems to be working properly. What does that mean to me now? I'm increasing the amplitude. That it's not within spec. I'll change carrier frequency to something a little lower. So let's go way lower. Oh, that's interesting. So the amplitude modulation is it? Oh, it turned the amplitude modulation off itself. I think I went too low, and I guess you can't do AM modulation with only 100 kilocycles for the carrier. Let me go to 1 megahertz. Now the AM modulation is back on. So, alright, I'm changing the amplitude of the carrier frequency. Now this is not right. Maybe this is where that error code is coming into play. Oh man, I wish I could get this thing to stop. Well, I'll just turn off modulation. Oh, wrong button. Off amplitude. What I want to see is, does the output amplitude stay the same as I change frequency? So right now I have 33 megahertz. Just above and below these outer two lines here. Oh, I am lowering the frequency. And notice the output amplitude is jumping up and down as I change frequency. I'm going in 1 megahertz increments. So now I'm at 14 megahertz. Now I'm at 15. The output amplitude is changing pretty significantly, and now I'm at 16 megahertz. Now I want to be a little, I don't think it's in my scope though, because yes, as I go higher and higher in frequency, my scope might start to drop off because of its bandwidth limitations, but you can see it's going up and down in kind of a pattern as I go up in frequency. It's not continuing to go down, it's going up and down, up and down, up and down. Not supposed to do that. Whoa, just went way up. So, between 43 and 47 megahertz is quite a significant jump. And it's clearly a repeating pattern going, arr, arr, arr. But you know what? This is the kind of error I could live with to some extent. If I was going to use this for an alignment and I'm sweeping over a 10 megahertz chunk, it varying that much over the course of a few megahertz would definitely affect my alignment ability. It's varying, I don't know, what, 10%? That's pretty significant. If it was only varying up 1% or I could barely perceive it, that would be one thing. This is kind of bad. So now we're at the point where we're probably past the troubleshooting stage. Maybe, hopefully, now we're into more of the calibration stage. I don't know if I can. I don't know if I have some of the stuff I would need, like this nice new HP digital multimeter, but I might have to use an extender card, and I might need some fancier stuff. Probably not for the AGC though. I'll have to review the process. Maybe this will illustrate the problem more clearly. I set this up to sweep from 15 to 25 megahertz, which is the type of thing I might want to do for a TV like this. And I have it on a very slow sweep rate so we can gradually see the frequency changing Notice the amplitude is varying a little bit. It's subtle, but it is varying. Should not be doing that. I reviewed the service info, and unfortunately I didn't find anything obvious that might address my issue. The CW level sets the overall output level of the device. I didn't see anything about leveling the output as the frequency changes. So, I don't know. I may have to go on to online forums and ask for help. Something else I want to try doing is repairing my old board. This is that DAC, digital analog converter. It seems like a good place to start. This is an AD5820, also known as a DAC 1020. Very obsolete, no longer made, can't get them from any of the major supply houses. I need to go onto the gray market and buy one off of eBay. I say gray because most of them come from China. They could be counterfeit. A few U.S. sources, some have them that are really crusty ones from the 70s. Other vendors, you have to buy 10 or 20 at one shot for say $60. But I think there's one vendor for $20 I can buy one of them. So I'll keep poking around, see what I can find. The DAC 1020 is a National Semiconductor, slightly newer, compatible version of it. That seems to be the more available one, so that's what I'll try to get. Meanwhile, I would like to fix the rotary encoder knob on the front. Here's an exploded diagram of, well, how you take the thing apart. That is what I need to get to. There's an optical rotary encoder that actually has apparently a couple tiny light bulbs. I think they call them grain of wheat bulbs. It's a common issue with these rotary encoders where those bulbs go out. I don't know how to get to the thing. The one blog write-up I found about a guy who took one apart, his was a mess, and he just completely stripped the whole thing down. Took all the cards out, took the whole cabinet apart. I really hope I don't have to do that. I'm hoping somehow I can get the front off. Looks like if I take the sides off, maybe I can start getting at screws that hold the front panel on, and I'm hoping that I can just take the bezel and this stuff off and get to that. I think that might be being very overly optimistic. Other issue, the fan. I don't show it on here. The fan is crazy loud. I didn't realize it till I was playing around with this just now, because I had the TV on. I couldn't even hear the TV with that fan on. I'm not going to want to use this for any length of time on my workbench with the fan that loud. As one of you already mentioned, hey, fan technology has improved a lot. Try putting in a quieter one. Sure, I already looked online and didn't see anything about anybody retrofitting a newer fan into it. I don't know what type of fan is in it, what voltage it runs on, what dimensions it are. But for sure. So I don't know if it originally was that loud, or are the bearings or something wearing out on mine and it's gotten a lot louder. I have no reference other than I have two other HP devices. One's a little bit older, one's a little bit newer. Neither one is anywhere near this loud, so I suspect that the fan maybe is going out. Other than that, I think we're in pretty good shape. And even as it is, I will try using it for a TV alignment. In particular, I'm curious how the markers work out. It has a Z output, so it has the usual X and Y outputs you'd put to an XY monitor or oscilloscope, but it also has a Z output. So if you need to have a scope that has a Z input, which controls the intensity. So what you do is you dial in up to 5 different frequencies, and as it's doing a sweep, when it encounters one of those frequencies, the intensity gets a lot brighter. So you get a bright spot rather than a birdie marker like I'm used to seeing, where you get a squiggle, you get a bright dot, which is a far more precise way to do it. I'm really psyched to see how that works out. So we're not quite done yet, but boy, I've gotten a lot farther than I thought I would just in 2-3 weeks of effort. As always, thanks for watching, and thanks for the encouragement and suggestions.